Vectors, we have seen this before. Vectors have two properties, magnitude and direction. So they can change in magnitude and vectors can change in direction as well. Okay, there are two types of vectors, free or non-free vectors. That is one way of categorizing the vectors. So let us look at so force, etc. These are non-free vectors, because you need to specify the point of application of the force as well, along with the magnitude and direction to completely define the vector. And in case of direction vector or angular velocity vector, these are free vectors which need not, in which case you need not specify the point of origin or point of application. Okay, the vector, the most common coordinate system is a Cartesian coordinate system, where I, j, k are unit vectors along x, y, z axis. So we have seen this before. So let us go to the cross product. Even this was discussed earlier. So cross product of two vectors u and v. So the resultant of the cross product will be perpendicular to both u and v. To find the direction of the resultant vector, you need to use your right hand rule. So let's say we're doing the cross product of two vectors u cross v. Okay, so you always use the right hand rule. So your fingers should be pointing towards, the four fingers should be pointing towards the direction of the vector u. So let's say this is the direction of u, and your fingers need to close, right? The direction in which they close should be the direction of vector v. So u cross v, and the direction of the thumb will give you the resultant of u cross v, the direction of the resultant of u cross v. So we have also discussed how we can write u cross v as a product of two matrices, u tilde, the skew symmetric matrix, multiplied by the column vector v. Okay, this is the traditional definition, uv sine theta times k cap, where k cap is the direction of the resultant of u.